are recording. So whenever you are ready.
I'm sorry, Julia, say again.
Whenever you're ready.
Oh, all right. Well, we will commence then. Good afternoon, everybody. I hope it's a pleasant day there in Harrisonburg and that you have a good show underway. I am mighty disappointed that I could not be there, but on the other hand, I'm very thankful to have the opportunity once again to address the American Truck Historical Society, a privilege I surely never expected to have, but have been lucky enough to do a couple of 3 times here in recent years. And today marks yet another one and coincides with 50 years of ATHS. So congratulations to all of you who have made this wonderful organization go for all these years. And what I have for you today, well, first off, there's the Cummins engine family tree. And I recognize that's pretty much an eye chart viewed in this venue. I hope to actually publish this thing someday so that it might be available in a readable form. But I put all of this up here just to kind of display the tremendous variety of products that we have had over the years. But what we're going to do today is focus in this area right in here. Can you all see the cursor? Does it appear on the screen?
Yes, you can see it.
Okay, so that area right in there, which if we zoom in on it, looks like this. The subject of the talk today is the history of our engine that was the bread and butter truck market engine for 70 years with Cummins diesel, the H, and its descendants. And again, this is what it looks like on the family tree timeline if we zoom in on it here a little bit. This is a lot of material. You may have noticed in the program that we're scheduled for an hour and a half today. And I think it might quite not go that long, but it is a great deal of material. If at some point partway through, there's a consensus in the group there to take a break, I'm certainly agreeable to that. Somebody just shout and let me know if we want to do so. If not, we'll press right on through. And the approach that I'll be taking with this today, so that that you have an idea how this is going to go, is that I'm going to take each of the product lines or each of the branches on the tree. We'll start at the beginning and work all the way through its history. For instance, with the original H, the 672 cubic inch inline 6, we'll start at the beginning and carry it all the way through to its end of production. Then there'll be a rewind, and we'll go back here to 1945 and pick up the NH-743 and its sibling, the HR, and we'll go all the way through that branch and then rewind again to 1960 with the 855 and press all the way down through to the end on that. So from a chronological perspective, we're going to whipsaw a little bit, but I think it makes more sense to tell the story that way, and hopefully it will go okay. Well, we got to begin with this guy, of course, in any kind of tale about Cummins diesel. Plessy Lyle Cummins, who was the father of the automotive diesel, just turned 30 years of age when the engine company was established in 1919. Mr. Cummins preferred to be called CL, and so I will endeavor to do that, mentioning him throughout this, although I occasionally lapse and use the more familiar Plessy as though I knew the man, which unfortunately I did not. But in any event, I will do my best to refer to him as CL. As the business got underway there in the very early 20s, we started out building this, which we refer to today as the VID, HVID. That name comes from the Danish gentleman who controlled manufacturing licenses for it here in the United States. So built that for a few years and then went to something a little bit better. And then something still a little bit better than that. And finally, toward the end of the 20s, arriving at something that was very much better. This is the Model U, We refer to the U as the engine that saved the company. And the reason for that is that it was the motive power behind all of Clessy's promotional work in the very early 30s. It was a Model U that powered the Packard limousine, the Daytona Beach speed records, the New York to Los Angeles truck trip, and the car that was entered in the 1931 Indianapolis 500. The four-cylinder variant that you see right here was 382 cubic inches and developed about 40 horsepower in stock trim. It started production in 1928, and then in 1929, CL introduced the single disc fuel system. And that was very, very important in that now all the ingredients are in place, and that has set the stage for what we're here to talk about, which was the original Cummins Model H. CL and his chief engineer, Hans Cummins, were hard at work on this thing all throughout 1931. And the first prototype was completed and started on the test block in the engine plant on November 19th, 1931. You can, take a look at this picture and you can see the N14 in it, so to speak, with the cam follower covers here by the block, the three heads of 2 cylinders apiece. As originally went to production, the engine was 4 7/8 bore and 6-inch stroke, which yields 672 cubic inches. Or for those of you who prefer to think metric, that's 11 liters. The engine had 2 valve heads back in those days. And of course, the famous single disc fuel pump here was originally rated at 125 horsepower at 1800 RPM. And again, at this time, CL was very much in the midst of his promotional efforts for the company. And so that engine was very promptly installed in the Indiana truck that you see in these photographs here. Driven up to the Indianapolis Motor Speedway in December of 1931. It ran 14,600 miles, averaging about 43 miles an hour throughout that period of time. This was nothing more than a demonstration of the engine's durability and reliability. The drivers for this little escapade were CL himself, who's right here. This fellow standing next to him is Ford Moyer. And this one over here behind the driver's door is David. Mr. Evans was also the fellow who drove the 1931 Indianapolis 500 Cummins race car. So the three of them shared driving duties. They were occasionally assisted by a fourth person who is not here. CL and Evans actually stayed on board the entire time, with the exception of Christmas Day. CL actually went home for Christmas and by all accounts slept, and then went back to the truck on the next day to wrap the thing up on the 26th of December. The truck carried a 1,000-gallon fuel tank in the back, and that got them through 10 days, at which point some fuel was added. And speaking of adding fuel, food, supplies, people, whatever needed to be transferred in and out of the truck was accomplished by the method that you see right here, where a passenger car would be brought up alongside and they would run at a relatively low speed and pass back and forth whatever was needed at the time. The truck did suffer a couple of mechanical problems along the way. The nut that secured the steering pitman began to work loose, and at another point, a couple of the cap screws that secured the crankshaft rear seal began to come loose. And these were both repaired while the truck was underway. They devised a system of ropes, planks, and whatnot, and slung it underneath the truck while it was running, although granted at a very low speed, but it was still nevertheless underway. And would put some worthy volunteer underneath the truck and effected repairs while it was moving. They had started out with this splendid plan for providing the drivers with hot, nutritious meals, but as the days and the miles wore on, that began to get less and less a matter of importance. And it went from hot meals to cold sandwiches and eventually to bananas. In 1932, the company began to push for trying to get the H into the truck market. And the vehicle you see here is in fact the very first heavy duty on-road truck in the United States to be powered by a 6-cylinder H. We were unable at the time to get any of the truck manufacturers to actually install the engine on their assembly lines. So Cummins made a deal with White to deliver some trucks to Columbus that had no engines. And the 6-cylinder H was installed in the truck here in Columbus. That photograph right there was made here in Columbus, Indiana, of the first truck. The fellow at left is a guy called Clyde Tatman, and he is the man who drove this thing to the West Coast, having never driven a heavy-duty truck before. And that was his plan, and that he wanted an individual who was not familiar with the vehicle and who would be fairly likely to inadvertently abuse it en route, again, to show how durable and reliable it was. The fellow on the right is Jay Chambers, who was one of the lead men in the plant, one of our top mechanics here in Columbus at the time. 4 other trucks were so outfitted and driven to the West Coast, and they were placed in service with Purity Stores, which was a grocery store chain in San Francisco, and went to work with Purity there by May of 1932. We also sold 10 engines in 1932 to Indiana Truck. 2 of these were used by White Motor Company as demonstrators, but most of them went to a firm called Intermountain Motor Freight, which was owned and operated by a fellow called Mel Savage. This outfit is among those that later merged several others to become Pacific Intermountain Express. But these engines went to work on the San Francisco to Salt Lake City route at 68,000 pounds gross weight. We know only with regard to these 2 makes that in 1932, we sold 5 H's to Gottfredson and 2 to Nelson Lamoon, and unfortunately don't know anything else about those. We also sold 6 engines to Sterling, and of those, we know that at least 3 went into service with Valley Freight Lines of Fresno. They were running from San Francisco to Los Angeles via the old US 99 Central Valley route over the Grapevine back in those days. I really like this picture here. That's the installation in one of those Sterlings. And that's a really slick, clean installation. Nice work by the guys there at Sterling. And Sterling then advertised factory availability of the Model H late in 1932. And we also had just a couple of more sales here. Remember, this was in the startup days. The overall volume in 1932 was quite small. But we sold 2 engines to Lynn. And we know only that those went into service with municipal road agencies somewhere in New York State. And then 1 engine to a truck maker called Kleber. And we think that one was also in service with Valley Freight Lines out in Fresno. There was also a 4-cylinder variant of the H went into production in 1932 and rated at 85 horsepower. I mention this only to highlight the fact that the 4-cylinder H is the engine that we went back to the Indianapolis 500 with in 1934. And in the early 30s, of course, the 2-stroke approach to diesel power plants was very much growing in interest. Of course, with GM diesel going into production with those. And CL had viewed it as a worthy possibility for quite some time and thought, well, what better way to test it than to put 2 engines that are otherwise identical into the Indy 500, one of them being a 2-stroke, one of them being a 4-stroke, and see what kind of results we get. Interestingly enough, you can see that the car with the two-stroke engine did finish the race and didn't do terribly bad. The car with the four-stroke engine was out after only 81 laps. However, it was due to a transmission problem and not an engine problem. After the race was over with, though, the two-stroke engine was in very, very poor condition, and CL concluded that it had not shown any particular advantage, and as a consequence, Cummins never fooled with the two-stroke approach ever again. Pardon me. There's a fascinating story about what happened to the two-stroke engine after the race. It's one of those urban legends that goes around, and it involves CL being so unnerved by the results that he threw the two-stroke engine into a river. The story is completely untrue, as we have the engine and have always had the engine, but it's a great and marvelous goofy story. If you have an opportunity sometime, I'd be glad to share it with you, but we'll not include it here today. Upon bringing that car back to Columbus and having no further use for the two-stroke approach, the frame in it was extended such that it could accept a six-cylinder H. And one was installed, as you see here. That engine was supercharged. And that car was taken to Daytona Beach again in 1935 and established yet another new record for diesel-powered automobiles, at that time reaching 137 miles an hour. The fellow at the wheel of the car here is a gentleman by the name of Bill Cummins. And his presence in that car began to set off confusion about the name of the company that we suffer with yet to this day. This six-cylinder H, of course, we still have this car outfitted, as you see here. And the particular six-cylinder H that's in that car is the oldest known surviving H in the world. Well, the various racing exploits there at Indianapolis and our early experience in truck service quickly led to improvements on the Model H. By 1935, we went with larger crank journals. The mains were increased from 3 1/4 inch to 4 1/2 inch diameter. And with that change, the engine was boosted up to 150 horsepower. And then in 1937, we added supercharging. The original supercharger arrangement was belt driven off the crank. And then in 1942, we went to a gear driven arrangement. In either case, that air handling improvement brought the engine up to 200 horsepower. What is this performance really like? And let's compare it to modern day, if we could. This is just an ordinary torque curve plot with engine speed and engine torque up here on the left. And for reference to something current, I've put the torque curve of a modern day X12 500 on here. And then these are the torque curves of the two existing very early H models. This is the naturally aspirated 150 horsepower rating. This is the supercharged 200 horsepower rating. And as we go through this talk, I'll continue to update with other engines as we go on through here. And the colors actually exist for a reason. Gray will indicate naturally aspirated. Throughout here, red will indicate supercharged. So by 1940, of course, we're on the cusp of the great unpleasantness around the world. World War II, from Cummins' perspective, was largely a naval affair. The reason for that being, in the run-up to the war, the federal government had taken a look at supplies of all sorts of raw materials, among them being fuel, and had decided that diesel fuel and similar distillates would be allocated entirely to the Navy, whereas the air and ground forces would be allocated gasoline. And so as a consequence, Cummins diesel products went largely into warships during World War II. And since we didn't have much of anything big enough to be main propulsion, we sold an awful lot of ship service generator sets. However, as the war dragged on, The Army did notice that their original plan for using a great number of small, roughly 2.5 ton trucks didn't work quite as well as they had thought. And so, and to push industry for 5 ton, 8 ton, and 10 ton trucks. And a number of these began to be fitted with diesels. And so Cummins did power about 5,000 trucks during World War II, principal among them being the Federal 604, which was used as a heavy equipment hauler and tank retriever. When we get to the tremendous post-war expansion in the American economy, I often tell my kids that very nearly everything that we enjoy and rely on so very much today was built in the generation or so that followed World War II. And there were an enormous number of things that one could pick from here to show Cummins diesels at work in that environment. But I thought this one was particularly interesting. And so I've tossed it in here kind of just for grins. In late 1947, out in California, the Palomar Observatory was being built. And the very, very large reflector type telescope there was fitted with a 1,000-pound mirror. And it needed to be brought up to the top of the mountain where the observatory is. And so this heavy hauling outfit that operated Sterlings with HB 600s got the contract to make the move. And here are a handful of pictures of that operation that took place in November of 1947. The first day's action was from Pasadena to about 110 miles. I think that's probably this photograph over here because they appear to be on the multi-lane highway with a police escort. The second day was from Escondido to Rincon, about 20 miles. Over in here, I think. And then from Rincon up to the observatory itself. This was a 17-mile route, 7 miles or 6.5% grade. And it was not straight. There were a great deal of curves and switchbacks and the like. And as they got near to the summit, it being November, they began to encounter a lot of fog and snow and even hail near the summit, but nevertheless, the job got done. I thought it was also interesting to note how they managed this operation with a tractor towing and a tractor pushing. I think this guy right up here is key to the operation. If you notice in this photograph, I think the driver possibly calls out something to this guy who relays it to this guy who then hollers to the driver in the back truck or something along those lines. But in any event, they made it happen with a pair of 150 horsepower Cummins diesels. And here's a little bit of our advertising from the same time. This is Transcon Lines out of Los Angeles, running international West Coasters, also with the 150 horsepower, piling up 108,000 miles in 1 month with only 20 minutes downtime, at least so we claimed. There wasn't much technically changed then with the basic Model H then for many, many years. In 1954, we got the PT fuel system, and that changeover occurred bit by bit throughout the year. So it's possible to have a 1954 Model H that still has single disc or one that has PT, just depending on when it was built in the year. And then in 1958, the H went 4-valve. And that product became known as the NH-180, rated at 180 horsepower at 2100 RPM, and was standard power and the white 4400 TD King of the Highway, and also in the then new white 5000. So this is sort of a summary review here of the Model H. Again, back to the beginning in 1932. Here's the 6-cylinder engine that started out at 125, then went to 150 horsepower, and pretty much pressed on without significant change. The supercharged rating up here at 200 horsepower. Again, in 1954, thereabouts, the changeover from single disc to PT. Up here in 1958, then the change to 4. And we also offered very briefly the NH-195, which was the highest rating ever achieved on a naturally aspirated 672 cubic inch H. In 1969, we reached the end of the line for the H, at least as far as the on-highway market goes. The decision was made that year not to attempt to emission certify any Model H to the on-highway federal smoke standard. It was used a little bit by the industrial and off-road markets for just a short time after that. But essentially 1970 was the end of the road for the Model H. So as I promised earlier, that means we're now going to rewind and we will step back in time once again to World War II. In 1943, Mr. Cummins is 55 years old and he is serving on the United States Production Board as Director of Diesel Engine Production. The wartime conditions caused Cummins to eliminate several of its models and choose just a small handful that were most useful to the war effort and really concentrate on getting those done. The scarcity of materials made manufacturing difficult, not only for Cummins, but certainly everybody in the United States. But despite all of these challenges in the midst of the war, the fellows up in the engineering loft still had time to come up with this. And in 1945, we started production on the NH. The principal distinction here being we went to a 5 1/8 inch bore and to 4 valve heads. That yields 743 cubic inches, or again, for my metric friends, 12.2 liters. And the initial production right out of the box for the naturally aspirated rating was 200 horsepower. And we offered a supercharged rating also right from the start at 275. This will be the first place that you will notice a vibration damper to appear on an H. The earlier ones did not have one, owing to their lower rated speed and lower power. The trucking market adopted the NH rather rapidly. PIE began to convert from H to NH right off the bat in 1946. And by 1949, interestingly, McLean Trucking of North Carolina operated the largest Cummins fleet in the world. Also in 1949, we introduced the double disc fuel pump, which can be seen right here. And with that change, the supercharged NH was then offered at 300 horsepower and was also fitted with an oil cooler, which was a first for us. You can't quite see it because it's on the other side of the engine, but these hoses are running over to the oil cooler that's mounted over there on the exhaust side. Very nice picture here of a Mack doing some really heavy work in the forest of the Pacific Northwest, fitted with a 2.6 bits. And a terrific picture, as I said, but man, it bothers me to look at these guys standing here. I mean, I know this load is secured, but good golly, it looks like if anything went wrong, man, they're in a bad spot. But I trust that they knew what they were doing. So now that we've got these two NH ratings, let's add them into the picture here as well. This is the 200 horsepower naturally aspirated NH and where it lands in the great torque curve scheme of things. And here's the 275 horsepower supercharged 2.6 bits. So, and these torque curves are all fine and good, but what does it really mean in terms of performance in a truck? And here's a little bit on what things were like in 1950. An engine in those days was expected to go about 150,000 miles to overhaul, although there was a celebrated case of an NH that reached 300,000 in 1951. And an engine could be expected to run passably well, even if fairly well out of adjustment in a number of areas, and they invariably smoke to one degree or another. But how about road performance? Well, I put together a few analysis for the purpose of this briefing. And for our 1950 case here, I've went with the naturally aspirated NH at 200 horsepower. Conventional cab truck having a 5-speed main and 3-speed auxiliary and 6/16 rear end gears, running on 10 by 22 bias ply tires with a 12-foot high box trailer and grossing out at 70,000 pounds. And here's what we get. Such a truck could run 51 mile an hour flat out in fifth over and be expected to pull down about 4.5 miles to the gallon. Unloaded, also 51 miles an hour because it's gear bound. And then insofar as various grades go, well, I'm an Easterner, so when you say grade to me, I think of things like Fancy Gap on I-77 or Mont Eagle on I-24, which both are about 4%. Right up here. Okay, there we go, 4%. And so we find that we can pull those grades at about 14 miles an hour in second over. If we look at some of the kind of things that they encounter out west, with the grapevine being more like 6%, that gets you down to about 10 miles an hour in first over. Such was the way of things about 1950. In 1951, we began production of the horizontally arranged NH, which we referred to then forevermore as pancakes. And it was really the double disc pump that made this possible. If you notice the way the engine is laid out here, it has the cam side, push rod side, intake side down. And that is also the side on which the fuel pump and the air compressor would be mounted. Well, with it laid down this way, they can no longer go down there. They have to be relocated. So here's our air compressor out here. Back in the days of the single disc pump, of course, that thing was so enormous that mounting it out here simply wouldn't be possible. It's too big, it protrudes way too much, it's far too heavy. But the double disc pump, being a little bit smaller and lighter, allowed for a successful mounting here. Now this is actually a later engine, that's a PT pump pictured there. But in any event, the advent of the double disc allowed us to do this. And so the ratings, again, were pretty much all essentially the same. The model name inserts an additional H to indicate horizontal. And we continued to build Pancake 743s up until about 1965. And the vast majority of all the ratings we ever released were also available as horizontals. Why do such a thing, one might ask? Well, for starters, they got us into the bus business, which CL himself had tried to pursue some 20 years earlier without much success. All of these buses pictured here have the horizontal underfloor arrangement. This 1954 Crown Super Coach was the first diesel-powered school bus in the United States. And there were even a few that went into trucks, not very many, I think, but here's a remarkable example. The engine in this truck is actually down here under this drum box. And I understand this thing was actually, or this original concept was actually home built by Pacific Intermountain Express and then later taken up by Kenworth. Kenworth referred to it as the cab forward of engine arrangement. And some few of these went into service, not a great many. Again, in 1954, with the introduction of the PT fuel system, of course, NH engines began to get that across the board bit by bit throughout the year. And then in 1955, the news was that the NH went turbo diesel, as our advertising referred to it back in those days. In 1955, we released these two ratings here, the 250 and 300 horsepower, followed in 1956 by the 262 and the 335. The higher ratings suffered a little bit of an altitude handicap over the first two. Nevertheless, that's where we started with the very early NTs. The turbochargers in those days were made either by Elliott or by Schwitzer, but that didn't last very long at all. And Cummins was in business manufacturing its own turbo machinery by 1957. In 1958, we had kind of an across-the-board performance bump on pretty much everything in the product line. The supercharged NHs the 300 went up to 320, the 2.6 bits went up to 290. The turbocharged engines all got a bit of an altitude boost, and the naturally aspirated NH went from 200 to 210 and 57, and then up to 220 in 1958. And that lands us then, of course, with the legendary NH-220, which by the very late 50s and all into the early 60s becomes very, very much widespread. It was standard power in the Dodge N-Series in 1959. It was available in the Ford H-Series. Denver, Chicago trucking had 400 tractors with NH-220s. And the bulk of the Navajo fleet was predominantly NH-220s in those days. Meanwhile, up at the higher end of the horsepower spectrum, the NRTO was at work. Again, that's the 335 horsepower rating. This is a Kenworth 953 up here in oil field service. This is actually an Australian road train. That's a Foden S cab over, towing a road train somewhere in the Aussie outback. And down here is a 335 powered White 5000. White called this particular tractor the Turnpike Cruiser. It was put into service specifically to operate on the New York State Thruway at loads in excess of 100,000 pounds. I'm guessing maybe you didn't expect to see this in an ATHS talk, but I wanted to toss in something that helped indicate how very, very widespread use of the NH was. Of course, it was very big in the trucking market, but had applications of almost everything you can imagine everywhere else. And this is one of my very personal favorites, the NASA crawler transporter that went into service in 1966. Now, when I say crawler transporter, we're talking about this gray base down here that runs on tracks and hauled the entire Apollo, Saturn V stack and gantry from this building over here where it was assembled out to the launch pad. And this thing was powered. Its motive power was actually a very large Alco diesel. Its onboard electrical power was generated by a couple of very large White Superior diesels, but its emergency electrical backup power was provided by a pair of NH-743s. And again, this went into service in 1966 and was used all through, in fact, the space shuttle program. It was constructed and it was built by Marion Power Shovel, and they made their bid to the government on the basis of weight. They actually included in their quote that they would charge the government X number of dollars per pound, and it depended on just how much the thing wound up weighing. And over here, this little goober in this old faded picture right here, that's me. And this is the Apollo 16 stack out on Launch Complex 39 in December of 1971. And so here's our recap then on the NH-743 as used in on-highway trucking. Again, down here where we start, this is the 200 horsepower original naturally aspirated rating, which was then bumped to NH-220. Throughout the 60s, it had a couple of turned down economy ratings, the NH-E-195 and NH-E-180. Whenever you see that E turn up back in those days, it's a reference to an economy rating. Here's the supercharged 2.6 bits up here, which was bumped to 290. Then for the 60s, here's our limited use of the double disc pump on the 300 that was also bumped to 320. And we introduce a new color on this plot here. The green indicates turbocharged, and here are the to initial turbocharged, or rather here's the initial turbocharged rating, the NT and the NRT. They were then followed a year later by the NTO and NRTO. Again, here was a very briefly lived economy rating out here, and another short-lived NTO 280 rating in the very early 60s. Once again, in 1969, there was a decision point reached, and that decision was not to attempt to emission certify any supercharged or turbocharged 743. The old NH-220 naturally aspirated was derated down to NH-200 for just a year or two into the emissions era. The 743 continued to be used by the industrial and generator drive business through about 1974, but then that was the end of the line for this product as well, which means we have to rewind again. In this case, we rewind back to 1948 for the introduction of the model HR. This is our actual advertising at the time that had the curtain being pulled on the new HR. The HR is a 743, again, fitted with 2-valve heads rather than 4-valve on the NH. And as it originally went to production, was rated at 165 horsepower. By 1949, we added a 225 supercharged rating. And then in 1950, there was 175 horsepower fast rating. The HR turned up in some buses as well. Again, this is not a horizontal application here in the Beck Silverliner. It's a conventional upright HR 743. Beck's design philosophy, as I understand it in those days, was rather to mimic General Motors buses, but to use Cummins power rather than Detroit diesel. And it's easy to see why, because the Detroit diesel approach in those days was to fit the engine with 2 4-cylinder Series 71s, each with its own transmission and driveline. And I can't imagine what it was like to operate one of those. But in any event, here's the Beck with the 2-valve 743. Also, the very early Freightliners, I think, tended to have either Buddhas or the HRBS. And again, that's the supercharged rating at 225. I've seen a handful of HRs turn up in whites throughout the 50s, also in some Lin half tracks. But for the most part, I think its production volumes were never terribly large. And here's the rather straightforward summary on the HR. Again, the 165 horsepower rating, which got the 1958 performance bump up to 175. The fast rating was eventually bumped to 190 and was available all through the 60s. The supercharged rating was bumped to 240, but then discontinued in 1961. Again, you've heard this story before. Come 1969, the HR was also a casualty of the 1970 on-highway federal smoke standard, and that marked its last use in on-highway trucks. So we rewind, and this will be the last rewind, interestingly enough. We come to 1960 and the introduction of the 855. This was achieved by going to 5.5-inch bore, and with the 4-valve heads and PT fuel system, the original naturally aspirated rating being 250 horsepower. The 855 introduced a number of other as well. One of them was non-flanged injectors with the rail and passages now drilled in the head, so that fuel tubing manifold that had for so long been a feature of the H and NH that you would see emerging from the sides of the heads here is now gone. It also has internal oil lines with the exception of the suck tube down here to the pan. But other than that, all of the number of external oil lines and hoses and whatnot that had appeared on the 743 are now gone, because the drillings are all here in the gear case and various other places. We went to 12 bolts per head, which was an increase over the 743, and these heads are in fact about 1 inch lower than they were on the 743. In addition to the bigger bore, the engine also has bigger valves. We went to 1 7/8 diameter valves. They had been 1 3/4 on the 743. The liners are also thicker, and the conrods are tapered on the ends. So a great deal of improvement launched all at once with the 855 there in 1960. Here's a look at the exhaust side of the engine. In the late 50s, or mid to late 50s, Cummins adopted an approach of using a variety of what were to be top secret code names for its engine development programs. I say top secret kind of good naturedly because some of them did leak out, others didn't. But the naturally aspirated 855 was developed under the code name Nelly, and the turbocharged variant was developed under the code name Nettie. As an interesting sign of the times, the 855 was never supercharged. There was no development work ever done using a blower on an 855. It was all either turbocharged or not. And at the time in 1958, 59, during the development work, there was a young project engineer employed at Cummins who was hard at work on this engine. His name was Jim Garrett. He was 25 years old, and he and his wife Ann were expecting their first child. Jim was putting in an awful lot of long hours, and one evening he remarked to him, he said, "You know, if the baby is a little girl, perhaps we should name her Nellie or Nettie." His wife Ann was not amused, and the baby actually arrived a little before Thanksgiving in 1959. He was a little boy, and his name is Jim Jr. The Nettie program for the turbocharged rating yielded the NT380, which was a little bit of an odd duck. It was rated at 2,300 RPM rather than 21. So it put a little outside of the normal truck rating and powertrain arrangement kind of business. It was originally released only to the industrial markets, and then in 1962 also offered in the automotive business. Like I said, a bit of an odd duck. Some of them were after-cooled, some of them were not. These are both pictures of NT380s. You notice this one is not after-cooled, while this one is. And this was the first use of after-cooling for Cummins in this big chunky box here that was cast right into the top of the intake manifold. In 1961, also the 280 horsepower and 335 horsepower ratings were lifted over from the 743 and put on the 855 platform, which is why those disappeared from the 743 chart back at that period of time. In 1964, Cummins launched one of the things that was a key feature of our truck business for many, many years, and that's what we called the custom rating. The first one was the NTC 335, and in the model name, whenever you see the letter C appear in this position right here, that indicates custom rating. It's also right here on this sticker on the intake manifold. And the whole concept behind custom rating was that you could order this engine at 335, but then via nothing more than a button change in the PT pump. Again, and that button is in here behind the spring pack cover right down here, that you could change the engine performance and go for 260, 280, 300, 320, or 335 horsepower, all just with a button change. So it could be readily tailored after it was in service to a different sort of task, different sort of fleet operation. In 1965, we followed with the NHC 250, which was a custom rating on the naturally aspirated product. That would give you either 225 or 250. And in 1967, we launched the custom torque ratings. Those had 35 to 50% torque rise, as opposed to the 8 or 10% that had long prevailed in the truck market. By 1967, the NH250 was very much replacing the NH220 as kind of the on-highway standard. And the NTC 335 was really dominating the upper end of the truck market in place of the older NRTO. Speaking of a 335, here's an interesting approach. The guys at Freightliner put this together, not just an engine, but an entire power pack. You notice this, the cooling system, the air intake system, the transmission, this entire shooting match is all bolted together with intent that you could swap it out and replace it with another one in 30 minutes. Right here are a series of quick disconnect fittings for a fuel supply and to connect with the lubrifiner down here. In any event, very interesting idea. I guess it didn't really take off. You never hear much more about it. But then a lot of things began to happen for us in 1969. One of them was that the Army selected the NHC-250 for use in its 5-ton truck. I have had some other sharp-eyed observers mention to me that all of these pictures here are actually not M809s. There are dozens of variants on this basic truck, and so I think my picture choice perhaps was not as accurate as it could have been, but I hope to convey the general idea. What's important about this from our standpoint is that this decision in 1969 marked the Army's full shift to diesel power away from gasoline. They had, of course, been stuck with gasoline principally in World War II and had carried on with it for quite some time. Throughout the 60s, they tried in vain to come up with the elusive multi-fuel engine that would burn anything, and had precious little success with that. And so in 1969, finally decided to go full diesel. Some 70,000 of these were built over the next 20 years in a lot of different variations, but all of them powered by the NHC 250, which was some very good business for us. Even more significant, in 1969, General Motors finally signed up to buy engines from Cummins. And of course, this opened a whole nother big piece of volume for us. And then also in 1969, we embarked on our own sort of power explosion. Now at this point, the 335 had been the top dog since 1956. But we began to go to work on doing a little bit better here with the 855 platform. In 1969, releasing the NT350, then followed the next year by the shiny 290, the NTC 350, which was our first product to be after-cooled on highway, with the exception of the oddball 380 that I mentioned a little earlier on. The NTA 370 also hit the market in 1970. That was our first engine to exceed 1,000 foot-pounds torque. In 71, the NTA 400, and 72, the NTA 420. All of these had the Cummins VT50 turbo with vane diffusers and the Econo Crown piston. And I invite your attention to this flanged aftercooler. That is, it has this flanged top surface up here. That'll be an interesting spotting feature later on when we talk about the big cam product. Very late in 1970, we also embarked on another interesting direction, and that was the introduction of the NH-927. This was aimed at a market that we thought at the time was worth trying to deal with, and that was to meet the emissions requirements without turbocharging. And so the approach was more displacement, rather conservative ratings. It was only built as the Super 250 and the Super 270. But the displacement was achieved by going to 6.5 inches on the stroke. And that was a little bit scary in and of itself, because nobody had touched CL's 6-inch stroke crank since 1930. And there were some attempts made to turbocharge this rating, and those attempts revealed the weakness in the crankshaft. And so I guess the rule of thumb there is don't mess with Clessey's crankshaft. The production of this thing ended in 1974. So there aren't very many of these that were ever in service or probably that survive yet today. The 927 did introduce a couple of interesting features that later turned up on the 855 product, and that was the alternator being driven directly off the crank nose rather than the accessory drive, and a much larger, more effective oil cooler on the discharge side of the water pump rather than on the suction side. And those can be seen in this photograph. You notice here's the alternator being driven directly off the crank. Here's the oil cooler that's on the discharge side of the water pump. I throw this picture in here for those reasons, and also to mention that if you study history enough, you find that there's not a whole lot new under the sun, really. And in recent years, there's been so much talk about the integrated engine and transmission packages, but it turns out those are really not new either. Cummins was doing it in the early and mid 70s with a firm called Sunstrand. And this transmission back here is the Sunstrand responder. And I don't recall specifically what kind of arrangement it was, other than that it was an automatic with infinitely variable ratios that was operated by hydraulic pumps and motors. And this particular engine is an NTC 250S. So if you ever run across an engine whose data plate ends with the suffix S, that engine was originally intended for use with the Sunstrand responder. Also in 1974, the company built its millionth engine. This photograph was taken in the Columbus engine plant. We know that this is an NTC 350, but unfortunately, we have never been able to identify anybody in this photograph. Those strange things that gets lost to history. By 1974, Cummins held 45% of the US heavy-duty truck market, and that number was getting larger every year. Here's some of the 855 performance torque curves placed on this chart again with comparison to the current day X12 500. Again, here's the original 855, the NH-250. Here's your NTC 290, 335. Again, here the NTA 370, which, as I noted earlier, was the first of our products to exceed 1,000 foot-pounds. And then this is one of the custom torque ratings. You'll see the kind of torque rise that was involved on those. In 1973, we began to refer to those not as custom torque, but as power torque. So if you remember encountering some of those, that's the same sort of high torque rise concept. Well, I thought 1974 might be another good point to do a performance evaluation on how things were at those times. By this point, an engine is certainly expected to go 350,000 miles to overhaul. And whereas back in 1950, that engine smoked to some degree most of the time, by 1974, visible smoke is illegal throughout the United States. In terms of road performance, I made these selections to do an analysis and went with the pretty common and widespread NTC 350, Fuller 13 speed with direct in 12th, 444 rear end gears, a cab over tractor, of course, because almost everything was cab over then, right? The 13-foot 6-inch high box trailer, and let's load it to 76,000 pounds gross. And here's what we get. 62 mile an hour flat out in 8th over at about 3.5 miles to the gallon. Unloaded, we can run about 68 because we're no longer gear bound like we once were. If again, we go look at the 4% grade, we can make about 24 mile an hour in 5th direct, which is 10 miles an hour faster than it was way back. So we're moving more weight. Again, this 76,000 pounds is more than what I put in the 1950 analysis. So we're moving more load and moving it faster, but the fuel economy is really about the same. And, you know, there's a reason for that. And that is that 1974 was kind of the end of an era. 74 was the year that the first energy crisis and fuel shortage came to light. So Cummins' immediate reaction was to introduce the Formula series. And the first of these appeared in 1975 with the Formula 230 and Formula 290. And these were achieved in a rather straightforward manner, whereas you had your traditional torque curve that reached rated at 2100. We simply pushed the rated speed back to about 1900 or thereabouts, which puts you in a little bit sweeter spot on the fuel consumption curve. And these all picked up 4 to 5% fuel economy gains over the traditional ratings. And then all throughout the 70s and 80s, we continued to release these from time to time as the market had need of them. The covers of Cummins annual reports are generally rather plain looking affairs. But this is actually the cover of the 1977 corporate annual report, and it's my favorite by far. That is a Big Cam 1, which was introduced that year. You can, if you look down here closely in the shadow, you can see Big Cam cast into the block here. You can also note the very large cam follower covers that easily give away a Big Cam. The essence of the whole Big Cam program was that the camshaft had 2.5 inch versus 2 inch internals, which enabled it to carry higher injection pressures with less stress. Note also the cross-bolted aftercooler, as opposed to that earlier cast unit that had a little lid up here on the top. This one is now cross-bolted through the side right here, and this is a good giveaway for identifying a Big Cam 1. Also, on turbocharged ratings, the Big Cams no longer have the aneroid that has been a feature of Cummins turbocharged product for so many years now at this point. And there is down here on top of the fuel pump, there's an AFC valve buried right down in there. And so this is a terrific improvement itself. The Big Cam also introduced top stop injectors and had a little smaller water pump impeller and a voluted cavity in the block to cut down on parasitic losses from driving the water pump. It was followed in 1979 by the Big Cam 2, which went to the demand flow cooling lube system and featured pulse tuned exhaust manifolds. In 1980, we added mechanical variable timing in order to meet California emissions limits, which were now diverging from the 49 state federal limits, and introduced the need to have California only ratings. So you began to see these throughout the 70s and much of the 80s. Also in 1980, we released the highest rating the highest truck rating, that we ever put to production on the 855 platform. That was the twin turbo 475. 1981 also saw the release of the first 1600 RPM rating of the 270, yet another effort at fuel economy. 1982 saw introduction of the Big Cam 3. And you see all of these interesting features here that were introduced on the Big Cam 3. One that I don't note here, but is very significant from our corporate history standpoint, is that the Big Cam 3 was the first Cummins product to begin to use Holset turbos. There were just a very, very few Holsets on the Big Cam 2s. The Big Cam 3 was not entirely Holset, but largely so. And then the Big Cam 4 was entirely fitted with Holset turbo machinery. The Big Cam 4, of course, well known for low flow cooling, and also the introduction of CompuCheck fittings. By this period in the early 80s, Cummins had 63% of the North American heavy duty truck market. And, you know, realizing, I mentioned much earlier that we referred to the Model U as the engine that saved the company. And we began to think of the H-NH-NT as the engine, of course, that made the company because we did so well in the truck market with it. And by the early 80s, we realized that we liked the 855 so much that we did this. What you see there is a big cam 3 that has every single last part on it, from the block and the crank to hoses and gaskets and bolts and such, suspended on wires and arranged as though it were an exploded parts illustration. This thing is in the lobby of our corporate headquarters in downtown Columbus, Indiana, and is generally open to the public. So if you ever happen to be visiting us, please do stop by and have a look at that. Even if the lobby happens to not be open for some reason or other, you can look right through the windows and also get quite a good look at it. But a remarkable tribute there to a remarkable engine. In 1987, we went with the new Big Cam 4, which introduced step timing control, in addition to the mechanical variable timing that had already been in place for a while. And then a few Big Cam 4s also had still had fixed injection timing. We also added the LF3000 combo spin-on lube filter that year. And most notably, the new Big Cam 4 had provisions in the block to install electronic controls, although they weren't in place yet, but we were making ready for them. The following year, the 88 Big Cam 4 went to reduced drain flow injectors and had a huge increase in injection pressure. Again, all of this work intended to meet emissions requirements. That big jump in injection pressure was something we really were not quite ready for. And as a consequence, the 88 Big Cam 4 product suffered an unfortunate blow to its reputation in the market. I mentioned the Big Cam Spotter's Guide, and we'll do a real quick look here. Again, for the Big Cam 1, look for that cross-bolted aftercooler on the intake side, as opposed to the big cast piece that was on the earlier small cams. Then here on the exhaust side, there are a couple of things to look for. One, notice the exhaust manifold here is kind of a log with 90-degree bends in it on the Big Cam 1. Over here, we have this swoopy aerodynamic kind of manifold going on. The Big Cam 2 got this swoopy aerodynamic exhaust manifold. And then the Big Cam 3 added the 2 combo spin-on filters down here for lube oil, whereas the Big Cam 1 and 2 still had the older cartridge type unit, just the single element. The Big Cam 4, of course, then is easy to spot with its unitized aftercooler, the crossover that goes around the front of the engine, the tiny little low flow coolant connections. So here's the summary, and man, this thing gets really busy when you're looking at the 855. I won't try to crawl through this entire thing in great detail, but note here again, here's the beginning in 1960 with the NH-250. And then I've highlighted down here when the various Big Cam variants came along. And you'll notice we get all the way up here to 475 horsepower on the 855. One of the things to note again is the color coding on here. Remember, gray indicates naturally aspirated. Green indicates turbocharged. There is no red on here because the 855 was never supercharged. Blue shows turbocharged and aftercooled. And one of the things that's interesting about this plot is that you'll see the areas that are green keep working their way down to lower and lower ratings here as time goes by. And the parts that are blue do the same thing. They keep working down to lower and lower ratings as time goes by. The reason for that is that that was the air handling that was necessary to keep meeting the changing emission standards as we went through the 70s and into the 80s. Coming out of the 80s, in 1990, we launched the N14, and we're now into the last segment of of the history of this remarkable product. Still at 855 cubic inches and with 4 valve heads, but the N14 is most notable for having introduced Select, which was Cummins' first full authority electronic control system. We also returned on the N14 to conventional high flow cooling and introduced air-to-air after cooling. Another very interesting aspect of the N14 is that at long last, the crankshaft rod journals were enlarged, going from 3 1/8 inch diameter to 3 1/2. That 3 1/8 goes all the way back to the original H. So that was really a long time coming. In hindsight, we probably could have called this model maybe the Big Cam 7 or something like that, because it also includes a number of features in the camshaft and injector trains of just enlarging stuff to handle larger loads. The rocker shafts for each cylinder are now separate, whereas they used to be shared by a pair of cylinders. The cam follower shafts were bigger, the rollers were bigger, and the injector lobes on the camshaft are wider. So this thing still has big cam kind of things going on in it. Also over on the other side, can't see it in this photograph, but the water manifold is now integral with the rocker boxes. And when we introduced this engine in 1990, it already met the 1991 US EPA on-highway standards. So we went from things looking kind of bad with the 88 NT to being a year ahead of the emission standards with the N14 in 1990. And to answer the question, was there an N14 that did not have Select? And the answer to that is yes, very much so. During the initial production run, the N14 could be had with Select or with PT. And the N14 410, in fact, was PT only. And so here's what an N14 looks like if it still has PT fuel systems. Here's your STC manifold up here on the rocker boxes, STC switching, PT fuel pump. But by 1994, that went away, and the N14 on-highway truck engine was Select only for all ratings. In 1994, we also introduced the articulated piston. And then in 1996, we went to the N14 Plus. The Plus principally is a reference to the electronic controls. And the major change there was that the ECM now began to broadcast on the J1939 CAN bus that was becoming more and more widely used for communication between various components on board motor vehicles. One of the other handy ways to spot an N14 Plus as opposed to the earlier N14 is that the exhaust manifold bolts had been horizontally in line from all the way back to 1931. With the N14 Plus in 96, those were placed on a diagonal layout. And then here's what N14 performance looked like by 1998. Interesting thing to call out here and looking at these torque curves, you know, all the ones that we have looked at previously have been rather smooth curved, and these are now very angular. And that is a ramification of the electronic controls, where you can use the electronics to shape this in almost any way you like. Here again is the N14 410, which was PT only, and it still has the rather smooth curve to it. But all the rest of this has the various straight lines and angles that are so characteristic of electronic controls. And at long last, we have an H-based product that is as good as the X12 500 in terms of the N14 500E here being very comparable to the X12 500. This is what the N14 ratings look like over the 10 to 12 years that they were available. Again, when we first started, the lower ratings could be had with PT or Select. The upper ratings here were Select only. And then here's the N14 Plus, eventually leading up to the N14 525E Plus. These again are coded blue, indicating that they're all aftercooled, and in fact, they were all air-to-air aftercooled. And if we take one final performance check here with the end of the line on this and look at an N14 500E with an Eaton Smart Advantage 10-speed and a 370 rear end gear. My, how the gear ratios have come down over the years. Again, we're back to a conventional cab. Let's put 90,000 pounds on this guy and see what we get. Well, we can run 71 mile an hour flat out in 9th gear and get about 3.5 miles to the gallon, or cruise in 10th and pull down about 4 miles to the gallon. Again, getting somewhat better fuel economy at much greater payload. But again, one of the other things to note is that the exhaust that comes out of this engine is far, far cleaner than any of the previous ones. And then again, when we look at grades, we've made some substantial improvement as well. The 4% grade, you can run that at about 30 mile an hour in 7th gear, as opposed to the kind of speeds that were prevalent years ago. We built the last N14 for the on-highway truck market in the United States in 2002. So right here ends this line that began back in 1932 with the original H-672. And that's the essence of the story for today, my friends. I thank you very much for your kind attention. And I hope you found this interesting in some manner. And if you should have any questions, I'd be more than happy to take a shot at them.
So if you have any questions for Keith, you can either just say them really clear and loudly, or if he doesn't hear them, I'll repeat them. Does anyone have any?
Excellent briefing, Keith. Thank you very much.
From my vantage point many miles away, that sounded a little like Tom Mullen, right?
You're right on. There is one question, Keith.
Yes.
What one, sorry? What about the Signature 600? Was it like the N14?
Goodness no. The Signature 600, which then was more commonly known as the ISX, was a complete clean sheet. Don't use any old parts ever over design. It had essentially no relationship to the N14 whatsoever, other than the fact that they were both built in the same place.
Was it not in the late 90s when they built it?
Yeah, the Signature 600 began to go to production in 97, 8, or thereabouts. So like I said, there was about 6 years overlap where we were building them both in the same plant. But other than that, they have no relationship to one another whatsoever.
Perfect answer to that. We have another question. Do they still make them in India?
The 855 and N14?
N14.
Absolutely. Yeah, the N14 is still built in a handful of places around the world. In fact, Pune, India being one of them. We also build some in China. And I think they may even still be turning some out in Sao Paulo in Brazil. You know, there are still a number of places around the world where the emission standards are such that the N14 and even in some cases the later 855s are more than suitable for the market. So they are still being built, but no longer here in the United States.
Any other questions? Oh, yeah.
Was the N14 only available up to a maximum of 525 horsepower? Never industrial, marine, or perhaps Australian rating in excess of that?
Yeah, the 525 was the highest U.S. on-highway certified rating that we ever offered. There were some off-road ratings that were a bit higher, and unfortunately, I don't have the numbers right here off the top of my head. But they weren't much. Certainly less than 650.
Okay, perfect. Any other?
Is this available someplace to come back and find it?
Yes. So It will be on the virtual site that you all get access to.
And is that a permanent thing or?
Yes, it's a permanent thing.
Do they make more than one turbo cord, or they only come from what turbo they make?
For the N14 now, what kind of turbos do they make?
Oh boy, I would surmise that the bulk of the N14 product these days is being built with an HT60 frame size, probably.
Oh, got you. Anyone know? Oh, sorry, you have another?
Is there a way of getting more than 5.5 miles a gallon though? What out of it? Probably 5.5.
Yeah, with regard to those fuel economy figures, please bear in mind that, and let me go back to one of these. You can have an enormous influence on fuel economy right here, with the transmission and the rear end gear, and then of course how much load you're carrying and whatnot. So I picked these conditions, just kind of that looks about right for maybe something running in the late 90s, and that's where we ended up. It's certainly possible to do substantially better than that. For one thing, if you were running, because 90,000 pounds is probably illegal in most of the United States, right? So just running at less load would make quite a lot of difference. But yeah, these were intended to just kind of show a comparative throughout the years. And please bear in mind, you can do a lot of things around juggling rear end ratio, transmission ratios, certainly even the engine rating itself, and get some significantly different results.
Do you know what the maximum the pyrometer is supposed to go up to?
Did you hear that, Keith? Oh, sorry.
No, not quite.
What's the maximum on your pyrometer supposed to go up to? That'd be your exhaust temperature.
I think I heard
what's the highest you can go up to on your exhaust temperature?
What's the highest temperature you can go up on your exhaust temperature?
Yep.
That's very much a function of the rating and altitude and a lot of other things. But in general, probably not much over 1,000 degrees Fahrenheit would get you in the right ballpark for most ratings. The newer stuff would be a little bit higher. Our Holset guys have done absolute wonders in terms of materials in the turbine and what they can tolerate. And the cylinder head guys have done the same sort of things with exhaust valves. So later, a more recent product would go somewhat higher, but as a very general rule of thumb, and again, this is spread across a lot of different circumstances and installations and ratings, but somewhere a little bit north of 1,000 degrees Fahrenheit would be pretty reasonable. Julia, I'd like to just mention very quickly,
Of course.
to remind everybody about the available books that are published on the history of the company. He's with the diesel. That's CL's autobiography. This thing is long out of print, and about your only hope is to look on eBay and see if they turn up. They tend to be very expensive when they do. The engine that could is a history of Cummins from the beginning of the company up to about 1994. It was published in 1997 by the Harvard Business School. This is also out of print, but these also occasionally turn up on eBay or in used bookstores and the like. The Diesel Odyssey of Classy Cummins is a biography of Mr. Cummins written by his youngest son, Lyle. We have these in our power store, and it is a really, really terrific work. I highly recommend it. Red, Black, and Global is a thing we published internally, and it covers the history of the company from about 1995 to 2011. And we have lots of these laying around. But the engine that could and Red, Black, and Global are both business focused and are about the leadership and management and financial aspects of the company. So if that's your thing, those are good books. If you're looking for technical stuff, you won't find a whole lot in those. Whereas Lyle's book about his dad is just loaded with all of Clessy's remarkable accomplishments throughout the years. And Lyle is one heck of a researcher. He has a remarkable position in writing this book, and that not only, like I said, is he number one, he's a highly skilled engineer himself. Number two, really dogged researcher. I mean, he hunts for the facts and he doesn't give up until he finds the facts. And then thirdly, he witnessed most of it himself. And so that's what makes this thing such a remarkable book.
Is Lyle still alive?
Yeah, Lyle is, let me see if I can stop and do the math here. Lyle is well up into his 80s, and he's really slowed down a lot. He was here for our 100th anniversary, but he doesn't, he's not terribly active, I guess I should say. But one heck of a first-rate gentleman to make the acquaintance of, and I am very fortunate indeed to have had a few opportunities to chat with him and correspond with him.
Oh, thank you.
Lyle is the only one remaining. Like I said, he's Clessy's youngest son. All of Clessy's children are gone. Of course, his siblings are all gone. So he's the only one remaining, and Lyle's son is the only one still in the trucking business. He is actually a design engineer of Freightliner.
Interesting. Okay, Keith, thank you so much for your wonderful presentation.
Thank you.
Great.
It was muchly appreciated by everyone here.
All right, well, very good. We have more in store tomorrow morning where we will